remember if I deleted my earlier ones. What can you do first here? You could multiply, sure, but the biggest mistake I see is somebody will tell me the answer is 28 over 8. And you could say it's 28 over 64, but what's smarter? What's the smarter? What's 4 over 8? 1 over 2. So see, this is even a more direct reason why I don't need or even want to make LCD, because I want to reduce everything in the first place. LCD is unreducing things, building some things up so they have the same bottom. That's exactly the opposite of what I want to do here. So now I can get what? 7 over 16. Cool. I like it. I love the looks I'm getting. What's happening? Yes? 8 times 2. Okay, maybe. What's up, guys? Yeah, I live off of questions. I don't know if you picked up on that yet. Don't give a shit about anybody around you. They're all like, oh, shit, screw them. Yes?
So you can't just multiply the top two numbers and the large numbers and then simplify and call it done?
Yeah. That's how they work.
Okay.
Yes.
But that's
what's happening?
Because why didn't you do that extra step?
What extra step? Oh, okay. It's not an extra step. It's, so if I do this, if I multiply first, then I have to reduce. I've made my numbers larger. It's not always going to be really hard. But you can imagine if I make these numbers bigger, it's going to become really, really gross at the end. Now this you can reduce. What goes into both of these? I see the look you just gave me is exactly why you want to do this. But yes, 4. If you divide by 4, what do you get? 7 over? Same thing I did. So I divided by 4 first, and then I multiplied. Here you multiply, and then you divide by 4. Math doesn't give a shit which one you do first.
Thank you.
Sure.
So which one would you use? The top one or the bottom?
Yes. You pick the way you like. I am highly suggesting you do this.
Sure.
Just to keep the numbers smaller. You don't want to let the numbers get big, because then you can make mistakes.
Okay.
Maybe. But if you love this way for some reason, I don't mind. It just gives you more practice to work with bigger numbers. I don't mind that. I'm not going to stop you. All right, I like it. All right. I think I talked about division. What do you guys know about? If I divide. Yeah, sure. Yes, ma'am.
From what I understand, last side is 4 over 9 and verse 16 over 2.
Yes. You multiply by the reciprocal.
Correct, yes. So you can
Does that sound familiar?
Yes.
All right. If it doesn't, hold on. I'm going to show you why. And again, you got to excuse me. I thought I did this, but maybe I didn't do this in this class yet. Here's a really insane way to write this, but it's completely legal. Again, what I'm about to do, you never have to do, and I actually, honestly, never want you to do this. To this poor problem. I'm going to show you why this shortcut works. So another way to write this is 4/9 divided by 2/15. Right? You see why you would never want to do this? This is like fractception. Fraction within a fraction. Right? With Leo to pop up. Hey, wait a minute. There's a train. No. Sorry. If you haven't seen it, take a notebook with you, take notes so you can maybe understand it later. Now watch. This is really kind of cool. Now, so far, this is like, holy shit, Jeff, you've made it so much worse. Thanks, good math teacher man, for making it look so much worse. But, now watch. This bottom sucks. What's the best number to have on the bottom? The best number to have on the bottom of something? 1. Because then you can just forget about it, right? And anything divided by 1 is itself. How do I make this become 1? It's divided by 15, so I want to multiply it by 15. It's 2 on top, so I want to have a 2 on the bottom. See how those would cancel? It would become 1. Go with it. Now again, let me remind you, because every time I do this, a student comes up to me and says, my teacher never made me do that. I'm not making you do this. And yes, that's an impersonation of you. But I'm showing you why this works. Now, I did something to the bottom. I can't just leave the top alone. I have to do the exact same thing, don't I? This becomes 1. So this equals that. That's why when you divide fractions, you multiply by the reciprocal, because it would work like this. I don't know if you guys have ever seen that explanation, or what if teachers told you why you multiply by the reciprocal? Have they ever explained why that's true? Bunch of dorks. That's the reason teachers exist. It's not just to say, do this shit. It's supposed to be able to explain why you do it. So what this becomes, so don't do this, please dear God, do not do that. But this is 4/9 times, and then I can attack it. I can reduce now, right? Yeah, remember, it's got to be something on the top can reduce with something on the bottom. You can never reduce across because you're not dividing across, right? So 2 goes into 4 twice. What can go into 9 and 15? 3. So then I end up with 10 over 3, which is what is a mixed number? 3 goes into 10. 3 times with 1 left over. So depending on what I would ask you to do as an answer, you can give it to me either way. So again, this was explaining why it works. You just do this, you multiply by the reciprocal. But now you've all at least have seen why that idea works. Okay, maybe. So math is not just a series of shit that you have to remember that your teacher said. Math itself makes sense, period. The teacher is supposed to be able to explain to you why it does. So let me have you guys try a couple on your own. Do these 2 real quick. What you got, Jeff? I don't know. Show me what you got. Yeah, sure, that'll work. Yes, sir. Yes, sir. Exactly. That's the first thing. I like it. I'm going to make one more here. And then you and I will do it together, okay? Yeah, I emailed her back. I sent her the homework sheet. Sounds like she got it. I think she sent me an email right when I was leaving the office, so I haven't looked at the last one yet. Send it. Well, she was worried about the new homework when it was due. So I told her the day of the test, you got some time. See again? Yeah, you got time on that. Remember, the homework corrections aren't due until the day of the final. So I forgot to say that to her. It's more important that you work on the new homework and you work on the corrections when you get time. The new homework is more important. It's better to keep up with the new homework and just do the old homework when you can. Correct it. Sure. Yeah. Okay. All right. You see, D's going to help me out. So D, on this first one, what will you do? Which one? Second one, okay. So this becomes 8 over 21 times 35 over 10. And then what can you do? Reduce, okay? So for example, what goes in here? 2. Are you guys okay? Now notice something really nice. 5 goes into 35. How are we doing so far? Are you guys okay?
No.
What happened? I'm sorry.
I messed up. 55.
What happened? All right.
It's 2.
Are you guys concerned about the way I chose to do it? Because it doesn't matter. What happened?
I was blowing my nose. Why the hell did you flip the 35 and the 10? I'm sorry, I was in the toilet blowing my nose. I had the boogies.
All right, this is why. I mean,
I don't know what the crossing and the thingy.
I know, I'm sorry.
He's looking it over so that he can multiply so that he can.
All right. I'm not going to redo this. I'm sorry, Sid. You have to come see me after. If you miss any part of class, I'm not going to redo it every time. But when you divide fractions, you do multiply by the reciprocal. And I showed everybody why that's true. But it is truth. So you multiply by the reciprocal, and now I can just reduce any way that I see possible. There are multiple ways to do this. So just because I choose one way doesn't mean your way was wrong. 10 and 35 both have a 5, right? 10 and 8 both have a 2. I mean, it doesn't matter which way you go. It'll all wash out in the end. So what I did was, D and I, we saw 2 goes into both of those, which is really nice because 5 goes into both of those, which is really nice because...
3 and 7 goes in both of those.
So 4 times 1, 3 times 1.
1/3.
So no matter what way you do it, you should end up with 4/3.
I got error. It does not come.
So again, so getting past that first step, what happened here that has people trouble?
It just went really fast. I don't know.
Okay.
Sorry, it was slow.
You got somebody has this written down, right? I'm gonna give myself some more room.
Yeah.
Okay.
I'm gonna have to go to the room second.
All right. So most everybody's cool with that, right? All right. Now, somebody else give me a way that they try to do this. Do it a different way. What'd you do first? Yeah.
I did the 8 with the 10.
Oh, okay. That's the same thing I did. But let's see, you could do this, right?
Yeah.
What goes into both of these?
5.
So it'll be 7 and 2. Okay. Yes, ma'am?
Question. So you're just finding like the common factors that they have and then just dividing them. It doesn't matter if you start from like 2 numbers, like
Yeah, whatever's on the top is being divided by everything on the bottom. So let me do this. I'm assuming something that maybe I shouldn't assume. 35 and 10 both have 5 in common, right? Is that cool? So 35 is 5 times 7. 10 is 5 times 2. So those would, of course, cancel. 5 divided by 5 is 1. So that's really where the 7 over 2 comes from, right? Divide this by 5 and left with 7. Divide this by 5 and left with 2. Say again?
so you divide it by the same fraction and then you could take one from like 10 and 8 for the
Yes. So now I can say 2 goes into 8.
Yes. 1. Okay, because yeah, I get it.
All right. All right, guys. Let's do this. Let's take a giant step back. Okay.
Oh, yeah.
and you reduce that, and then you kind of put it left side. He's not.
All right, guys, stay with me. All right, this is going to be like an insane amount of work that I hope to God nobody does, but I'm going to show you everything involved that's kind of behind the scenes over there. So isn't this equal to 4 times 25 over 9 times 15? Is that step cool? So I multiply, but not really, because those are going to get gross. So what I want to do is find anything that's the same on the top and bottom, because then those things will cancel, right? Something divided by itself is 1, so they effectively go away. Is that part cool? Is that part cool? No? What's happening? Are you guys?
Yes.
I feel like some of you guys are just here physically, but not completely. Okay. All right. So now 4 is 2 times 2. 25 is 5 times 5. 9 is 3 times 3.
3 times 5.
All right. So if you really had to, but I hope you don't, you could do this. You can see why this method would get gross, because you have numbers with a lot of parts to them. You need to be able to bypass this. But see, what can I cancel? 5s. So what's 4 times 5? 20. And what's 3 times 3 times 3? 27. All right, so looking at this directly, so that's the answer, and that's the reason why it works. What goes into both of these? 5. Those 5s that we killed. So instead of doing all of this, I'm just going to say, let me just kill the 5, and I would be left with 3. Let me just kill the 5, I'd be left with 5. Nothing else cancels anywhere. 4 times 5 is 20. 9 times 3 is 27. So that is what we're doing. We're trying to kill the common factors. If I said multiply 4 by 3 and then divide that by 3, would you do any work? I hope not. You just go, well, the answer is 4. You just undid what you said to do. If I said multiply all this by 5 and then divide it by this times 5, well, those 5s cancel. They go away. I multiply it by 5 and then I divide it by 5. So that's effectively doing nothing. So that part can just become 1 and effectively go away. How are you guys doing about that? So, are you trying to follow?
I'm like writing down all this stuff and my brain is still like, sorry, it's not happening. I guess that knows blowing time screwed me.
Alright, so what's 4 divided by 4? 1. So what's 2 times 4 divided by 4? 2, because 4 divided by 4 is 1. So you're left with the other guy. Are those two things okay? What's up? 4 divided by 4 is 1. So 2 times 4 all over 4. That's 1. We established that is 1. So I'm left with 2, right? Is that cool? If I have a number that's on the top and the same numbers on the bottom, they will cancel. Why? Because this is what operation? Division. And what's this operation? So since they're opposite operations, these will cancel.
So you don't always have to cross cancel. You could take from the one above.
Yeah, we do that all the time, right? If I said reduce this. In fact, some of you guys that are having trouble, I bet you're able to do this. Guys, everybody, reduce that. Can you reduce that fraction?
Yes.
Yep, by 6. By 6. 6.
Over.
I'm with you guys, don't worry. I'm waiting for everybody to kind of get there. Alright, so what'd you guys get? Alright, if you're able to do this, period. Because what you just did is 18 is 6 times 3. 24 is... Now, did you actually do that? No, I'm sure you did this. Divided by 6, right?
Yes.
But do you see how that's the same thing more directly? Just the 6s that are there just kill each other already.
6 divided by 6 is 6.
Yes, exactly. So that's why they effectively go away. It's times 1 by everything else, so I'm just left with everything else. So this is 1, so I'm left with 1 times 3/4 is 3/4. I like it. I'm not sure what's happening. If I manage to make this seem more complicated than it is, maybe.
So that's a 3/4, right?
Say again?
That's a 3/4.
Totally. Yes. Yes.
I'm still at one for the first problem.
No. Sid, are you cool with that?
Yes.
Okay, now
I
watch.
understand that.
Why does anything change? If 18/24 is 3/4, why would it be different just because I put it next to something else? Couldn't I still do the same thing I just did? I'm building up to something here.
See, this is where you're losing.
No.
This part right there.
Anywhere in the universe. Now watch. What is 18/24? What is it? Anywhere in the universe I see 18/24, I can replace it with. Okay, so why is this any different? How do you reduce this?
So it'd be 3/4. Got you.
And then it's 3 times 3. 4 times 5. Okay. All right. That was the next step. Now, let me.
When you do the fractional y, do you reduce the second part? Like 3/5. You reduce 2.
What happened? Say again? Can anything else cancel? No. Okay. Because I wanted to focus on this guy. Right? Now watch. So this was, before I started writing all over, it was this, right? Is that cool?
Yes.
Now watch. What's up? I'm sorry. What's up? Okay. So if I wrote this instead, yes.
Okay, so I'm getting this here. What I'm still not understanding was that original problem that you did, the 8/21 divided by 10/35. I don't understand why you flipped the 35.
All right. I know. I'll do it again. I'll do it again because maybe somebody else needs to hear it. Okay. I'll do it again. But is this?
I'm like, why?
What's going to happen here? Is that any different than this? Not really. 24 is still on the bottom. It doesn't matter that it's on the bottom over here. It's still on the bottom, so I can still do this. All right, I want to make sure everybody's cool with that idea. If it's on the top and the other thing's on the bottom, I can kill the common numbers. It's the same problem here. I just moved those.
As long as there's something.
Yeah, there's a 6 on the bottom, there's a 6 on the top. Those 6s kill each other. They don't care where they are on the bottom. Something on the bottom, something's on the top, they can kill each other. Because again, it would all end up over each other anyway. That is over that.
Even if that 24 was on top of the 3?
Well, no, because that would not be what I just said. One of them has to be on the top, and the other one has to be on the bottom so that they'll cancel. If they're on the top together, they want to multiply together. They don't want to cancel each other out. So, for example, if I had 3/5 times 3/10, does anything cancel?
Yes.
No, nothing cancels. Because this wants to be 3 times 3, right?
Yes.
There's no division. Are there any 3s on the bottom?
No.
Are there any 5s or 10s on the top? So there's nothing that will cancel.
Cannot get 1, 2.
So this is multiplication. So anything on the top has to have the same thing on the bottom so that it will cancel. Because then it would be multiplication and division. They cancel each other. If they're both on the top, that's just multiplication. There's no cancellation that can happen then. So this would be... Alright, I like it. Alright, so real quick. Let me re-go over this. So if I had 4/5 divided by 8/15. I'm just going to do this one more time. Please, dear God, again, this is just an explanation of why the reciprocal thing works. Never do it like I'm about to do. Unless you really like it, which is crazy. Isn't this 4/5 divided by 8/15?
Yeah.
Same thing. That looks really gross, but I don't care. It's the same thing, right?
Yeah.
I like it. The best number to have on the bottom of something is 1. How do I make that become 1? Well, it's divided by 15, so I'm going to multiply it by 15. How would it make the 8 cancel if I had an 8 on the bottom? Wouldn't that become 1 then? Okay, good. And if I multiply the bottom by this, I better multiply the top by this. I got to do the same thing that I did on the bottom, I got to do it to the top also.
Flip it because the bottom becomes 1.
Now that's 1. So this equals this. 4/5 divided by 8/15 equals 4/5 times 15/8. I reciprocated. Because that's what I would do if I wrote it out in this gross way. So the shortcut now is you do 4/5 times 15/8, and now you can cross reduce. That's the shortcut. This is why it works. And again, you're still not going to crazy, but that is equal to this, which is equal to this, so therefore that equals this. They're equal to each other. The only physical representation of this I could ever come up with, go with me for a second. Division, how do we define division? If I have 6 apples and I got 2 people, each person gets 3, right? If I'm nice. Alright. Or if I had 6 apples and I wanted to put them in 2 crates, I would put 3 in each crate evenly. You with me? Well, let's say I see 1 crate, and I can only see half the crate. There's a lid on the other half. Go with me. This is kind of freaky. I don't want to say this. It's been a while since I've done this. So, oh yeah, that's right. So there's 2 oranges in like half the crate. So there's 2 oranges in 1/2 of a crate. How many total oranges are there going to be if it's full? No. If I see 2 oranges here, and it's half of it I can see, and the thing is full, how many total oranges are there? This is not a math problem. This is just there'd be 4 freaking oranges, right? So somehow 2 divided by 1/2 is 4. It's got to be. That's the physical representation of that. I see 2 in 1/2 of a crate. So the whole crate should have 4. So if I multiply by 2 over 1, I do get 4. So that is the physical representation of why we multiply by the reciprocal. Okay, there's 2 different ways to explain it. I can't come up. Yes?
You only do the reciprocal method when you're dividing?
Dividing.
Okay.
That is how you divide fractions, is multiply by the reciprocal. That's how you do it.
Because it'll cost it somehow.
Always. When you divide fractions, you multiply by the reciprocal. That is the way you do it. I like it. Let me see. So come at me again. What was that first problem I had up here earlier?
8 over
The-
21 divided by 10.
8 over 21?
Divided by 10 over 35.
Alright, so then the first step would be to make this 8 over 21 times 35 over 10. And now any way that you can see works will agree with anybody else as long as you all do every step correctly. It doesn't matter what you divide first. Just like if I said to factor 18 all the way, well, one person did 2 times 9 and somebody else did 3 times 6. Oh shit! Who cares? In the end, you're both going to agree, right? So it doesn't matter the path you take, you're going to end up in the same place. So whatever you see first, so if you see the 8 and the 10 both have a 2, so you can kill that 2 out of both of them. That's the first thing I saw. And then 5 and 35 are nice, right? 5 goes into 35. 7, and then 7 goes into 21 3 times. So really the problem with this problem becomes keeping track of who's left alive, right? The survivors. You want to get them out. I keep thinking about zombies. 4 times 1, 4. 3 times 1, 3. Or 1 1/3. Cool. How are you guys doing? Some of you guys look like you want to hurt me. Try not to let that get to me personally. You gotta get jumped in the way of my car. Now, some of you guys might just be bored. I don't know. So hopefully some of you guys are kind of bored maybe. This is old news. If this is not old news, if this is something you've never really understood or it's been a long time, then you got to ask questions. I love it. That's what I love about teaching math. It's coming up with a different way to say something. Yes?
Will you be here tomorrow?
Actually, yeah, but for a department meeting.
Huh?
The only times I'm on campus on Fridays is for meetings. And there actually are, every Friday after this, I'm going to be having some kind of meeting. So that's the only reason I'm on campus. Okay. What was the second problem I put up here?
77 over 1.
Oh, 77 over.
Divided by 88 over 25.
Well, actually, I mean, yeah, so the first thing you do, flip this dude. Okay, one of these markers. All my markers are dying. Oh. And now you just attack them with whatever you see. So this should be pretty straightforward. What goes into both of those? 11.
7, 8,
What goes into both of those?
1, 5.
Well, let's do this.
I'm 5.
Now you're 5. Oh, you're 5. Hold on. So 25 divided by 5 is 5. 125 divided by 5 is 25. But then 5 goes into 20. You can keep going. So now keep track of your survivors. 7 times 1. 5 times 8. 7/40.